A lot of people like this part of the course because it's that one simple idea of where does it start and what's the change that we use in all different ways in all different directions. Oh, I haven't handed this out yet. And so every different way that we look at it reinforces the same idea. Okay? And so if you didn't get it Wednesday of last week or Thursday of last week, well, don't worry, because we're going to keep talking about it over and over and over and over again. But eventually you do need to get it. And once you start getting it, all the pieces come together. Okay? So, everybody got that? No. So, we're going to, on the last day, we had a table, and the y values, or the values here, were given to you. And you had to figure out what the change was, and you had to figure out where it started. And then we could do things like write the rule, or we could graph it, do different things like that. How is this one different? Well, this one gives you the rule, doesn't it? So what we're going to do is we're going to look at the rule, try to figure out what it's telling us, and use that to fill out the rest of the information. Justin, what do you think? Yep. Okay. No, that's great, though. That's exactly what we're going to do. Jamali, what do you think? The last number in the rule tells me what? Did everybody hear that? Jamali said the last number in this rule, in this case, the way that this is written, that number there, the one that's not multiplied by x, the one that's just plus or minus something all by itself, tells us how much for 0. Or in other words, tells us where it starts. Very good. Now what does the rest of the rule tell me? Justin, what do you think? That it goes up by 2. Exactly. Very good. So the number that's multiplied by the x is what it's changing by. So if I start at 1 and I go up by 2, where am I next? Fantastic. So you can continue that if you want. And then we just follow the pattern. See how easy that is? What's next? Brandy, what's next? 5. Walker, what's next? No. We're not going up by 3, though. We're going up by 2. Very nice. So, and I can show it this way, because it's linear, so I don't want it to change. So plus, you don't have to show this, but remember, this is how, if I gave you a table, this is how you would check it. Every time I'm going up by 2. If I change it to 3, it'd be nonlinear. It would be a different kind of pattern, different kind of graph. It's still something maybe you could graph, but it would be a different kind of graph. Okay, very good. And then I can use these numbers to graph. But here's the other thing that's really cool. If I know where it starts, I go to the graph and I start there. And this is where it starts. It always starts on this axis. That's what we mean by where does it start. You see what I mean? So it starts at 1. Then I put a dot on the vertical axis here at 1. And then what am I changing by? I'm going up by 2. So I'm going to go over and up 2. And 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 I'm going to notice, just put your pencil down for a second and watch. If I look at this point, 3, 7. Remember when we did plotting points earlier last week? If I go over 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, right? There's 3, 7. But when we were just plotting points x, y, it doesn't mean a whole lot necessarily, but now we can see how, like, I counted over 1, 2, 3, and I counted up by 2s to get up to 7. Like, we can start to see sort of how these different pieces fit together. Okay, and again, I just want you to watch. So put your pencil down and put your eyes up. When we draw a line, we're going to use a ruler, okay? and our line's going to go like this. It's not going to stop at the last point. It's going to go through all the points, and we like it to go all the way to the edge of the grid. Okay, so we don't stop here. We go all the way to there. What do you think? How could I tell if I made a mistake? Yeah, if the line wasn't straight. Or what if one of the points was over here? Would you have a linear relation that would go like this? Or something? No. So if they don't form a perfect line, we've plotted it wrong. Because we know that this is linear. We just did a learning goal on that. We just talked about that on Thursday. Look at that rule. There's no squares in it or anything like that. It's a straight line. So all my points have to form a perfect straight line. Okay, nice. Let's try another one. Something different about this one. What's different about this one? Kaden? There's no plus thing. See, and this is what we want to start recognizing. When you're looking at a rule, you're looking for those two parts. What's the change and where does it start? So what is this rule giving me? What does it have? How much it goes up by? What is it? 4. So I know this. Plus 4. Plus 4. Plus 4. Plus 4. That comes from here. The number that's multiplied by x. If I knew where to start, I could figure out where to go from there. Does anybody have any ideas about what they think it might be? Do you think you just pick your own number? Just guess? I'll choose 7. Hayden, what do you think? What do you think? You were going to say 0 too, Justin? You had your hand up. What were you going to say? 0? Makes sense, doesn't it? Because if it's 4x plus 0, you don't have to write the 0. We don't have to write plus 0 because it doesn't do anything. So very good. If that was your hunch, if you had any suspicion, it's like plus 0. So what does that tell me? It tells me when we start at 0 here, I'm 0 there. And then we already know the pattern, so what's going to be my next number? Up 4 to 4. Up 4 more to 8. Up 4 more to, and you just keep, and you can use your calculator if you want, plus 4, plus 4. If it was a bigger number, sometimes we will use bigger numbers. You might even have a decimal, although not really, not today, but it's possible for sure. And you could use your calculator to figure that stuff out. 12 plus 4 more is 16. So this point here is over 4 up 16. And this one's not labeled. So whenever you have a grid that's not labeled, it's your job to label it. So I'm going to do that. 1, 2, 3, 4, 5. I like to count 5 and plot up 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So 4, 16 means I went over 4 and I go up 16. So 5, 10, 15, 16. You don't need to do this. I'm going to plot that point first and then see if the other points form a line with it. Does that make sense? So I'm kind of checking my work. Okay. I started at 0. Go over and up 4. 1, 2, 3, 4. Over and up 1, 2, 3, 4. Over and up 1, 2, 3, 4. Over and up 1, 2, 3, 4. And sure enough, looks like it fits perfectly. Remember, draw a straight line with a ruler. All the way to the edge of the grid. And again, that idea of a staircase is really important. I go over 1, up 4, over 1, up 4, over 1. over 1 up 4, over 1 up 4, over 1 up 4. I'm going up by 4 every time. Any questions about that? All right, very good. Everybody got it? Here's another one to try. I want you to try this one and think about it. Think about the rule. Think about what it's telling you. See if you can start filling in the table, but we are going to do this one together again. But I want you to see if you can, because it's a bit different, see if you can guess. And I will give you this little hint or this little piece of advice. Even if it looks kind of different, we're still doing linear relations. What are the 2 important things about a linear relation? What are they? Who can tell me that? Or one of them? Anybody? Savannah, what do you think? What are the 2 things that we were just talking about? Kind of, but remember, I mean, it certainly has to do with those 2 things. Donovan, do you remember those 2 things that I was saying are important? Marley, what do you think? Say again? Well, that is what we talk about when we plotted points, but that's not what we're talking about now. But this is good because I'm going to keep repeating this until when I say, hey, what are the 2 important things about a linear relation? Everybody in here says where it starts and what is it changed by. And even if it looks a little bit different, that's still what you're doing. So see if you can use that idea to think through this one. What part of the rule tells you where it starts? What part of the rule tells you what the change is? Very nice, folks. I see a lot of people on the right track. When I look at this one and I compare it to the other ones, if you want to watch up here, it might help. If you're not sure, you might have guessed, but you're still not sure if you're right and not as confident, I don't know. When I look at this example here, this was the number where we started because it's the number all by itself. And the 2, which is multiplied by the x, tells me what the change is. So even though this question looks a little bit different, I still approach it the same way. I still do that same thing. What's the number by itself? What's the number with the x? And Justin, what did you tell me about this one? It's backwards. You might think of this one as like it's backwards. So what's the number by itself? 16. So where does the 16 go? It goes there where it starts. And it was very interesting how many people had a hunch of what the minus x means. Who can describe that in terms of the pattern, what minus x in the rule means? Noah, what did you do with it? So you're going down by how much? Yeah. And so every time x is changing by 1, so I'm going to go down 1. And I saw a lot of people put that because the subtraction means you're decreasing, you're going down. And it's by x, by 1x, or like there's a 1 here. You could think of it that way. If it was going down by 2 x's, you'd be going down by 2 every time, but in this case, we're only going down by 1 every time. So 15, 14, 13, and 12. 16 minus 4. Take a look. Put your pencil down and watch. It's 16 minus x. If x is 4, it does mean 16 minus 4. I mean, that is what this means if we think about substitution that we did so long ago at the beginning of this course. 16 minus 4 is 12. So you can also think about it that way, like it's an equation that you're solving. Okay, let's go ahead and fill out this graph 2, 1, 2, 3, 4, 5. I know some people hate graphing. And we're going to be doing a lot of work with graphs, but usually you're not the one making the graph, but once in a while you will. So you do need to practice this. Like, don't just refuse to do it because you hate it so much. I know some people do. I know. But try anyway, okay? 1, 2, 3, 4, 5. Try to make it look as nice as you can. 4, 5. 1, 2, 3, 4, 5, all the way up to 20. So this rule tells me I start at 16 and I go down by 1 every time. So down 1, down 1, down 1, down 1. Every time I go over, I go down 1. And this graph is going to eventually get to 0. If this graph was talking about something in real life, what might it be talking about? Very nice. How could it be talking about money? You're spending $1 a day, maybe. Very good. Maybe you're buying popcorn every day, right? For $1. And you started with $16. You spend $1 a day, you're not making any money. How many days until you're out of money? 16 days. That's pretty easy because the math is so friendly. Those are nice numbers. But that's the kind of pattern that happens in real life all the time that being able to do some math around it can be useful. If the numbers weren't as friendly, like I have $16 and I spend $1 a day. That's not very normal. Most people, it doesn't work out that way. You know what I mean? Any questions about this? Okay, we're going to try some practice.